Ionic compounds are compounds that are formed between a metal and a nonmetal. And we've just looked at the periodic table, and we know there's a stair step that starts up there at boron and steps its way down, and that separates the metals on the left from the nonmetals on the right. We also just finished looking at charges of things, and we know what kind of charge do metals have? Positive. So metals are cations. What kind of charge does a nonmetal have? A negative, so it's an anion. So another way of looking at an ionic compound is a compound formed between a cation and an anion. Another group of compounds that I want to talk about so that you'll see the difference, because there's different rules for naming ionic compounds versus molecular compounds. And you've got to recognize it as a different kind of compound so you know how to name it. Molecular compounds are made up entirely of nonmetals. So in other words, molecular compounds are made up of stuff from that right side of the stair step. And a lot of times molecular compounds have common names, like water. Okay? Another molecular compound that you guys know is this. What's that?
Carbon dioxide.
Carbon dioxide, right? CO2 sometimes we say, but we all know that's carbon dioxide, don't we? So if you can name that one, you can name any molecular compound. But let's focus on ionic compounds for a second. I think, yeah, on your sheet, I give you this example as an ionic compound. NaCl. Do you guys recognize that as a metal, the Na, and a nonmetal Cl? What's the name of that? Sodium chloride. If you can name that one, you can name any of them. That's sodium chloride. Do you see that sodium chloride is formed from a cation, which is sodium? What charge does sodium have? +1. And an anion, which is the chloride ion, which has a -1 charge. So when I take this sodium with a +1 charge and the chloride with a -1 charge and I put them together, the charges balance each other out, don't they? They cancel out so that it's neutral. This is the sodium ion. This is the chloride ion. So I take the ions away from the name and I have sodium chloride. So ionic compounds are always still going to be named ending in "ide", just like the anion. What if I were going to write the formula for calcium chloride? What's the symbol for calcium? Ca. What kind of charge does calcium like to have? +2. Chloride, I just worked that one with sodium chloride. I know that's Cl with a -1 charge. Now, when I take these and put them together, the Ca with a +2 and the Cl with a -1, if I just stick one of each together, they're not going to cancel each other out. Right, I would end up with an overall +1 charge. Y'all, they have to neutralize each other. So do you see that means I'm going to need 2 chlorides to go with this 1 calcium? If I have 2 chlorides, I've got 2 -1s. And I put it with this +2, and then it would neutralize each other. So the formula would then be CaCl2. That's how I come up with those subscripts. How I refer to this is swap and drop. What does swap and drop mean? It means you take the charge of each ion. You just take the number. You don't actually take the sign. You take the 2 that's on the charge of the calcium and you make it the subscript of the chlorine. And you take the -1 that's the charge on the chlorine, and 1 becomes the subscript of calcium, and that's how you have your formula. Questions on that?